This video is going to look at how to connect a vibrating wire strain gauge to the Linx data logger supplied by GeoSense. It'll also look at how to connect a thermistor to the same data logger. If we look at the quick connector, this is a 5-pin connection. There are 2 inputs for a vibrating wire, 2 inputs for the thermistor, and where the cable is a shielded cable, such as from a vibrating wire strain gauge, the central connection is for the shielding. The position 1 and 2 and 3 and 4 are able to be swapped around without affecting the measurement, but the color codes as shown here are what would typically be used when connecting a vibrating wire strain gauge. The connectors are either supplied connected to strain gauges when ordered at the same time with custom manufacture, or they're supplied separately and need to be wired up. So in order to change the connection, you'll need to remove the small screws from the quick connector and then remove each part. And we can see on the inside we have the 5 connections, and these are labelled, though it's a little hard to see here. So I'm going to start by connecting a thermistor to a quick connector, which means we'll be using connection point 3 and connection point 4. First we need to prepare our cable by stripping the sheath from it, and then by cutting it to length. So it's useful to twist the cables before removing the sheath, and these should be supplied like this, or with pre-exposed cables. This is a 10K thermistor, which is important when we come to set up the data logging software. So first we need to cut the cables to the same length as the internal sockets of the quick connector, and make sure they're trimmed carefully. This is so that there's no exposed copper, which could short circuit inside the connector and affect our measurement accuracy or ability to measure. Once they're trimmed, we need to thread on the outside nut first. Then the rubber washer is placed inside the main body of the quick connector, and that's threaded over the cable as well. There are 2 washers supplied. The thicker washer is useful for this application. Finally, we are clear to screw our 2 wires into positions 3 and 4 on the head of the quick connector. So these can be pushed in up to the whole length of the cable, leaving just the sheath outside the copper plug. And once connected, the screws can be tightened. And if this is just a thermistor connection, we're good to begin measuring. So just quickly ensure that the cables are firmly bedded and can't be pulled out under mild pressure. And then the main body can be screwed onto the head of the quick connector, and the nut at the back screwed on, which will ensure that the cable has proper strain relief, is held firmly, so there's no pulling on the cable will pull on the internal connections to the copper. And this is now ready to connect to your Linx data logger. If we were doing the same thing with a vibrating wire strain gauge, we would simply connect the 4 cables into the same position, and the sheath into the 5th central position. Finally, the quick connector has a small tab which needs to engage positively with the tab in the Linx data logger, and then the quick connector can be screwed on. This is a sealed connection at this point. We can now begin setting up our data logger in the Linx software. I'm going to begin by turning on 2 channels. I've connected in 1 thermistor and 1 vibrating wire strain gauge into these channels, so channel 1 and channel 2. Channel 1 has the strain gauge, channel 2 has the thermistor. In each case we can adjust the name of our sensors. So channel 1 having the vibrating wire strain gauge. I can give the model numbers used, so this is a embedment strain gauge, which you would use for the hotbox application, and we can put the serial number of that sensor in as well. Now on the right I've got my calibration certificate, which has the gauge and batch factor to correctly measure information from the sensor. So the critical things is we need to use a linear factor, and we need to multiply the gauge factor by the batch factor before entering that into the linear factor box on the software. So 0.924 by 3.718 is 3.435, and we can just copy that and paste that directly into the linear factor. This means that we're now going to be measuring units of strain when we do a calculation. Also, you need to know the kind of thermistor supplied with your strain gauge. In this case, it is a 3K thermistor, and on channel 2 we have a 10K thermistor, which is the kind of thermistors used with the dedicated thermistors supplied for the hotbox application. Once these are set up, and enable real-time data. So turning on real-time data, we can see the temperatures and the linear conversion to strain of our outcome. So if we adjust channel 1, we can see now that we're showing B digits, which is the measurement we need to adjust our parameters, and we can see the actual hertz, the frequency the wire is vibrating at. So I'm going to go back to linear, so I'm going to paste the outcome in B, linear digits, into the 0 reading, and I'm going to update my settings one more time. This means we are now measuring strain relative to the first measurement from that sensor. So coming back and updating our sensor, we now see we're sitting at 0 on strain, and the temperatures remain the same, but the limits of linear digit and hertz measurements are still the total magnitude, but the linear factor has been corrected for the 0. So once your parameters are correctly set up in the data logger and your readings are suitable for use, we can then begin the data logging within the Linx data logger. So we stop real time and we come along into the logger configuration, and we'll set this up for how much we want to measure. So maybe one measurement an hour, or one measurement every 30 minutes or 50 minutes, depending upon your requirements. And we're going to turn on channels 1 and channel 2. And we're going to upload this configuration to the logger. Whenever we make a change anywhere in the software, we need to upload it to the logger. So when we begin data logging, it'll operate with the correct calibration settings and with the correct information. We can also set the period for which data logging will occur. So a final upload. And then we can use the large clear start logging button to begin our measurement procedure. So we'll double check everything, come along to we'll come into the start logging mode button. We'll tell it to begin, and it'll give us the final settings we have. It'll now take some time to churn away and begin the data logging. So don't touch the program and don't make any changes while it is attempting the start. And once the start's complete, your data logger is now set up. And after a few minutes, or you've had enough for a couple of logging intervals, you can come back and do a quick data download to confirm the correct operation of that data logger. Thank you for watching this video. If you have any questions, please do get in touch with your local PCTE rep, but this should serve as a useful guideline for the operation of the hotbox systems. Thank you.